type 1 versus type 2 error and which one is more costly. And you can imagine just evolutionarily that we developed sort of almost instinctive responses or decision rules that have absolutely nothing to do with doing math, that have absolutely nothing to do with whether or not we know probabilities. They just have to do with instinctively how our brains are hardwired to respond because certain kinds of errors are more costly than others. And then we talked about a third situation, which was the overconfidence and the whole test taking thing that we were talking about a minute ago, where you can actually show, and we don't know whether this is the correct answer or not, but you can actually show that it's possible to get incorrect beliefs, irrational expectations, in this case about your own ability relative to others, from a perfectly rational, unboundedly rational, correct, starting out with correct understanding of priors and conditional probabilities of signals, and applying Bayes' rule perfectly with unbounded rationality, you can wind up still getting irrational expectations about your own ability relative to others. Okay? And so what I want you to, again, as I said earlier, the math of that particular chunk of lecture, where we talked about conditional expectations and H, the precision, 1 over H, or 1 over the variance, whatever. Don't worry too much about the math of that. What I want you to sort of think about in terms of big picture stuff is this complicated relationship that we see over and over again between different kinds of rationality assumptions and different ways of relaxing rationality assumptions and the different implications that those assumptions have. Right? So this is a case where you have all of the assumptions that go into the model are perfectly rational, but the output of the model isn't. Right, and results in people having systematically incorrect beliefs about a distribution of conditional probabilities, which is a failure of rational expectations. And just to think, I just want you to be able to think somewhat richly about. In a lot of cases, there's no firm conclusions about these issues. I just want you to be able to think somewhat robustly and intelligently about them. Okay, so that's about probability inference and Bayes' rule. Next big topic we talked about was social preferences, and the main mathematical model that we looked at was the Charnis-Rabin model of distributional preferences. Right? Distributional preferences is a subset of social preferences. Social preferences means any possible preferences you might have over how things get distributed, including not only the outcomes of the distribution, but also the process by which the distribution was reached. Okay? Distributional preferences is a major subset of that, which is simply how do you feel about the final outcomes, you versus others, whether you're ahead or behind, whether they get more than you, or depending on whether you prefer perfect equality or whether you're just a rat bastard who always wants to sink his competition. And this is this section of the course is slightly different from most of the others because we don't have a particularly interesting standard model to start with, right? The standard model is pure self-interest, which is mathematically very uninteresting because it sets the other person always to zero. We don't care about the other person at all. So there's not sort of like in most of the sections of the class I've tried to start by saying here's a chunk of mathematical modeling that we can call the standard model. The standard model of social preferences is just this extremely simplistic assumption that we don't care about other people's outcomes at all, and there's no sort of mathematical formal framework that I can begin with and poke holes in. We know it's not. We can immediately demonstrate very easily that the assumption of pure self-interest is wrong, and from there we actually need to construct a model from scratch that we can start to test and poke holes in. Yes. That is so I talked about that briefly at one point, I think, although it might have been after class. You can, if you start thinking about altruism, simply caring about other people, it's perfectly easy to say, well, you're getting utility from that. It makes you feel good in maybe complicated ways. It makes you feel like you look good. It makes you actually feel, whatever it is, whatever the form of psychological, or maybe you get utility out of it because you think it increases the likelihood that you will live eternally in bliss, right? Whatever it is. And so since that's part of your utility function, it's still you caring about you. And what I would say is that that's not what a standard economist would say. That's what a philosopher might say, right? And that would allow us to draw, in some sense, a line. I've talked at a few points in the course about the line between psychology and economics. This would allow us to draw a line between philosophy and economics. Because a philosopher might find that a really rich vein to tap into. What is the true meaning of self-interest? Is there any deep fundamental concept of altruism? Even a standard economist would say, that is not actually going to affect. There's going to be no economic content to that. I'm simply going to define self-interest differently than that philosopher in such a way that my definition is shielded from that philosopher's sort of endless contemplation. And I'm simply going to say self-interest means you only care about your own outcomes. And that allows me to remain comfortably in the domain of economically important outcomes. Because the difference between self-interest and altruism for the philosopher doesn't actually have any economic implications whatsoever. Right? The only thing that has economic implications is the difference between caring about your outcomes versus caring about other people's outcomes. And philosophically, what we call that is outside of economics, because it doesn't change the predictions of our models one iota. Does that make sense? So sorry for the somewhat long diversion, but that is actually, I wanted to go into that a little bit because I feel like that's actually a really very relevant overarching topic of the class, is to sort of think about, we've been thinking about psychology all semester long, and I've tried to point out at different times places where, well, psychologically it could be this or it could be that, but for an economist it doesn't matter because the results are the same. Right? And really sort of knowing when you've gone too far into sort of navel-gazing psychological cogitations, and really understanding that at the end of the day, what matters is individual choices and how they aggregate to markets and economies. Yeah,
so I guess we can say economists don't actually care about the intention of why you're doing something, but what you're actually doing now.
So Ben's question is, we can sort of say the economists don't care about the intentions. Economists don't care about the intentions when the intentions don't make a difference to the predictions of our models. Now, we'll talk in a second about intentions-based preferences and reciprocity and wanting to be mean to somebody who's mean. There we care very much about the intentions of the individual, but only because the person in our model cares about the intentions of the other player, not because we as economists care about their intentions. We only care about their behavior, right? Okay. So the model is this thing with rho and sigma. And I found a convenient way to tell the difference between people who had been to that lecture and people who had just gotten a copy of the handout, because the people who had just gotten a copy of the handout refer to that as P and sigma, which is an easy mistake, but that's rho. And the model goes something like this. If you have some allocation, the utility you get from an allocation x1 and x2, where 2 is you, right? This is you, and that's the other, 1 is the other. Okay, and I'm going to get this wrong, and then you guys can correct me. It's rho times x1 plus 1 minus rho times x2 if x2 is greater than or equal to x1, right? That's right. That's that right. If you're ahead, rho is how much you care about the other person, and it's sigma x1 plus 1 minus sigma x2 is less than x1, right? So rho is how much you feel about is how much you care about other people when you're ahead, and sigma is how much you care about other people when you're behind. Just a little technical point that came up in office hours a couple of times, and I can't remember if it came up in lecture, but I think it didn't. There's some sort of debate or controversy about, well, what if x1 is equal to x2? In some places it was defined like this. In some places there was a equal under both of these inequalities, and which is it? And the answer is that if x1 is equal to x2, it doesn't matter. Because if x1 is equal to x2, these two things are equal, then the utility, then rho and sigma drop out. So it doesn't matter which piece of this piecewise utility function you choose if x1 and x2 are equal. Okay, so that's the basic model. And a good place to start would be, to convince yourself that you thoroughly understand why those different preference types that are defined by, why we can define certain parameter ranges of sigma and rho as defining certain types of social preferences. And I'm not going to go into that because time does not allow. But go back to that table, and there's a more exhaustive list actually in the paper. The part of the paper that talks about those different types, I think I didn't assign, so you don't need to go into that. But there's more about that in the paper in parts that weren't actually assigned. And then the other thing that we did with these parameters, yeah, go ahead. No, the question was, should we have the types memorized? I think that's probably, yeah, that's picking on. I'm not interested in. I just want you to be you should be able to reconstruct them, right? If I say, what's the kind of question I might ask? If I gave you a set of parameter values, you ought to be able to figure out what kind of motivations and desires and payoffs, psychological payoffs, do they seem to capture. And I wouldn't necessarily expect you to be able to say, oh, in lecture we called that Rawlsianism. But you should be able to describe, oh, this is someone who only cares about the person who's behind. Yeah. I don't have that memorized. You should be able to figure it out. Hang on. And you want, if you wanted to hurt yourself when you're behind, when you're ahead, and you want to hurt yourself. Oh, go back and look at that. I think the difference aversion parameters do capture that. I'm pretty sure. And if they don't, send me an email. Okay. Now, the whole framework of sort of 2 lectures worth, or at least a lecture and a half, of talking about the Charnas and Raven model, actually talking about quite a bit more than the whole topic of social preferences, was this idea of picking apart the ultimatum game. The ultimatum game is there's a pie, the proposer says this much for you. Basically, the proposer slices the pie, offers one of the slices to the receiver, and the receiver decides whether to accept that slice or throw both slices into the compost. Okay? You should understand the ultimatum game perfectly. And then we sort of ask 2 questions. Why do proposers give? Oh, by the way, you should also understand the Nash equilibrium in the ultimatum game, which is give nothing except anything. Okay? Under the assumption of pure self-interest. Okay, so then we picked apart proposer giving by cutting the ultimatum game in half and throwing part of it away and just looking at dictator games. Okay, and we talked about 3 different reasons for giving: generosity, face-saving concerns, and fear of rejection. And we went through a series of experimental tests. One of the themes of the course is this idea of how do we actually get serious about the scientific process. One of the big criticisms of neoclassical economics over the decades has been that we don't take the scientific process seriously. We observe very loosely something we think we see in the world, like, say, for example, the diamonds and water paradox. Do you guys know the diamonds and water paradox? Diamonds are completely, so before people figured out how to use diamonds for cutting and how to put diamonds on the tip of a circular saw, go back a few centuries, diamonds were essentially useless to human beings. Water, completely essential to survival on a daily basis. Diamonds, very expensive. Water, very cheap. Okay, so this was a nut buster for a really, really long time. People had absolutely no idea why this was the case. Right? Aristotle pondered it. Thomas Aquinas pondered it. People couldn't figure it out. And eventually, economists, not neoclassical, classical economists, Hume and Smith, figured out the laws of supply and demand, and they explained the diamonds and water paradox. But the thing is that whole style of economics basically observes something very roughly, comes up with a model that can explain it. Right? Let's make a bunch of assumptions that when we put them into a model, they will explain a certain outcome, and then let's say we're done. That's the model. And then let's use that model to predict things that we can't see. Like, what will happen if we impose this particular bizarre policy in colonial India, for example? Oh, it'll be great. Our model says so. Where did we get our model? We made it up. Right? We made a bunch of assumptions that happened to explain some things, and then we decided we would make a prediction about something we'd never observed, and it'll have a massive impact for several hundred million people on faraway continents, and we don't care. For example. And what we're trying to do here, and this is not exclusive to behavioral economics, this is true more and more in all of economics, but it's particularly true in behavioral economics, is to get serious about the scientific process, which is you observe something, you come up with a theory that can explain it, and then or maybe you come up with multiple theories that can explain it, and then to decide whether or not your theory is really right, or which of a competing set of theories is actually more correct, you come up with a prediction, a scenario, whether it's an experiment or some real-world thing that you could observe, in which the models make different predictions. And then you test them, and you go out and you gather new data, and you rule out some models, and the interesting thing about the scientific process is you can never prove that a theory is correct. You can only prove that a theory is not correct. Right? But you keep doing this over and over again. So now I've ruled out this model. This model, now I need another experiment that makes a different set of predictions I haven't observed yet. And so you're constantly looking for new predictions and new ways to test those predictions so that you can tease apart which model is right and which model is wrong. Okay. So you can and you should think about this process of picking apart the ultimatum game and this sort of endless series of different experiments. We saw quite a lot of experiments in that segment of the course, and you should think about that as a place to turn for really getting a robust understanding of how we go from initial observations, geez, people seem to be fairly generous, to a set of theories that could explain those results, but that can't be differentiated on the basis of those results. Right? We saw in the ultimatum game different reasons for being generous, different reasons for proposers being generous, couldn't be differentiated using only the ultimatum game. So now we come up with a new game in which different models make different predictions, the dictator game. Okay? And then we tweak the dictator game to tease out face-saving concerns, where a purely distributional model would make a different prediction than a model of face-saving concerns, et cetera, et cetera, et cetera. So go through that and really get a sense of how is the scientific process unfolding here. Okay, so these are the 3 different reasons we came up with for why proposers in the ultimatum game don't sort of violate the standard model of pure self-interest, which is to give nothing. And then we looked at why do receivers reject small, sometimes not so small offers in the ultimatum game. And we picked apart the ultimatum game in a different way, right? We came up with a set of games where you have something that looks like an ultimatum game, but there's one of the branches of the game, right? You have player 1 here who either offers a choice to player 2. Say, for example, we have the 8-2-0-0 choice over and over again, or has what I'm referring to. I don't think this is in any of the paper that we read or anywhere else, but I call it sort of the walk-away option. Right? So this is not a standard ultimatum game. This is an ultimatum game where player 1 doesn't just make slice the pie and offer the slice, but has to choose between slicing the pie and offering the slice, or just walking away with just slicing the pie and not offering, just dumping, like, here, take it or leave it. And that allowed us to look at different reasons why player 2 might accept or reject the offer that's made, if the offer is in fact made, by saying, well, what was the walk-away offer that player 1 didn't choose, and did that reflect nice or mean intentions? Okay. So that captures a whole bunch of different stuff. It captures a whole bunch of different distributional preferences. It captures space-saving concerns, which is preferences over other people's beliefs. It captures intentions-based preferences, right? Whether or not people care about how outcomes were reached. Was this fair? Was it nice? If it was fair or nice, maybe I want to be nice back to you. If it was unfair or mean, maybe I want to be a jerk back to you. And that covers the gamut of different social preferences. Another topic in here that you should probably feel pretty familiar with is how to tell whether a strategy profile is a fairness equilibrium. Okay? So if all we're looking at is distributional preferences, right, preferences over actual outcomes, the Charnas-Reagan type of preferences, or all we care about is what you wound up with and what your opponent or what the other player wound up with, then sort of game theory can handle this very easily, right? Because your payoff is just what's your utility function. It's not what's your utility function for your outcome. It's what's your utility function for both outcomes. But you could very easily imagine taking a simple game like the Battle of the one I actually can remember is Meet Me at the Station. I think it was 0-1-1-0, but I may revert. And you can very easily imagine applying Nash equilibrium by simply saying, well, instead of knowing your material payoff, I have to write a new grid in which I compute your utility function over x1 and x2 for x1 and x2. So, right, so suppose somebody puts equal weight on their utility and the other person's utility. Then you could simply plug in 10 and 10 here, 1 and 0 here, 6 and 6 here, and create a new game matrix with the utilities they get from their distributional preferences instead of just their own material outcome. We haven't done that. I don't know if I would expect you to be able to do that, but I'm simply saying that this model of distributional preferences doesn't present any particular challenges to the concept of Nash equilibrium. But a model of intentions-based preferences really kind of does, because now we have to care about not just the numbers in the boxes, but how people feel about the way the numbers in the boxes came to pass, right? And what kinds of nice or nasty intentions a particular strategy profile implies. So in the Battle of the Sexes, if you go to the opera and I go to football, what is that? We know that can't be Nash equilibrium under any reasonable, non-self-hating set of distributional preferences. But could it be a fairness equilibrium when we take into account something that cannot be directly observed in the payoff matrix, which is, did I think you were being nice to me or mean to me, and did I want to pay you back with niceness or meanness? Okay, so we have this definition of a fairness equilibrium, which is that a fairness equilibrium is a strategy profile. Right? We said people they get utility from material payoffs, mine and maybe yours and mine both, and then they get utility from psychological payoffs, being mean to someone who is mean, being nice to someone who is nice. And a fairness equilibrium we defined as a strategy profile in which each player is best responding to the other player, given their material and psychological payoffs, and beliefs are correct. Right? And it's the part of the definition of fairness equilibrium that really matters is the part where we say that for a strategy profile to be a fairness equilibrium, beliefs have to be correct. And so what we can do then is that we can test whether a particular strategy profile is a fairness equilibrium by beginning with that part of the definition where beliefs have to be correct. Because what we can do is, let's see, help me remember Battle of the Sexes. We had opera, football, and it's 2-1-1-2 like that, and then they just both get, this person likes opera, that's one liking opera. Okay, so if 2 goes to football, then it's like that, right? Is that does anybody remember? I'm sorry, I'm terrible with remembering the exact. No, because this person who likes opera better still likes going to opera a little bit when their friend goes to football. Is it 0-0? Well, let's just say it is. It doesn't matter that much. The point is simply I just wanted something on the board to point to. A strategy profile is opera, right? A strategy profile means what were the actions of both players, okay? And that defines a cell in a matrix, or it defines an endpoint in a game tree, okay? And so a strategy profile is a Nash equilibrium if it's a mutual best response on payoffs. It's a fairness equilibrium if it's a Nash equilibrium on payoffs and psychological, right, material and psychological payoffs where beliefs about intentions are correct. And so what you do is you start by saying, okay, let's investigate opera. That means we're going to this box. And the first thing to do is to say, given the actions in that box, they both went to opera, what must each player have believed about the other player's actions and the other player's beliefs about their actions? Okay, so you can figure out beliefs based on the actions that are defined by the strategy profile. Then once you figure out what those beliefs must have been, you can figure out whether each player's intentions were nice, neutral, or mean. Okay? Then once you figure out what those intentions are, you can figure out whether the other player, right, if player 1's intentions based on their beliefs must have been mean, right, then you know that the other player, you know what the other player's psychological payoffs will be. Right? If player 2 was mean to player 1 based on their beliefs, then player 1's psychological payoffs are going to be positive for being mean, negative for being nice.